Good morning, everybody. As I've been introduced several times, my name is Will Degner. I'm going to take you through a dashboard here, which allows me to tell the story of Asset Vision, if you like. Asset Vision is an incredibly broad and deep platform, and what I'm hoping to do here in perhaps 20 to 30 minutes is give you a really good idea of what we can do that will hopefully pique your interest, and we can deep dive should you need to at a later date. And I tend to like to start the story at the end, because we've mentioned already today the sort of traditional value and cost optimization stories. And if you look in the top right hand corner in my demo system, obviously I've got some estimated unused software, and this is a traditional value that people continue to use our software for. So identifying unused software, putting a value against that, whether it be RRP or the real cost that the customer is paying, and multiplying that by the number of instances that are unused. And this is repeatedly a return on investment that we provide. Now, another example of this is if there's a piece of hardware that's sitting around and no one's using it at all, it's just burning electricity. If we can apply a cost to that machine, how much a typical machine costs, we can again drive unused machine value. Another example, just sort of giving you an idea of sort of adding value to an inventory that you weren't necessarily thinking of, is we augment our data with either external data or customer data as is required. One of the examples we give here is we add warranty information. So for the Dell, Lenovo, HP and so on, as we inventory a machine, we'll reach out to those manufacturers and we'll drag down warranty information that you typically do through their web portal or whatever. But of course, if we have that in a single place inside Asset Vision, we can start to look at our machines and where they're going end of life. So quite an interesting way to use your inventory to look at future hardware spend. And last but by no means least, another traditional cost optimization story is audit exposure. So we can obviously identify what software you've got out there in the environment, which we'll talk about in a moment, and we can allow our customers to upload their entitlement information, which we process and work out the differences. And so we can identify an audit exposure. But really and truly, what we're after here is identifying what's being used. So that audit exposure, it may say I've got 5,000 licenses for Visio, I've got 10,000 installations, but once I start applying that usage information, it might turn out that I'm only using 2,000 of them. So suddenly my audit problem almost goes away. Okay, so again, sort of traditional cost optimization. So let's talk about how we get there. So we use effectively two methods to collect information, and effectively they are agentless, so we reach out across the network, or agent-based, so we put something on the endpoint. And I'm going to talk about both of those, and just to make sure that they're well understood and subdivided, as it were. So if I just dive into the sort of agentless approach, so what does this mean? So this means that we'll go into an environment and we'll install a piece of software inside their estate. Now, whether that be on a virtual machine or during a POC, it could even be on someone's desktop or laptop machine. It's got very low system requirements, and effectively what it does is it acts as a proxy, if you like. And the term we use here is that blue blob there, is the proxy adapter discovery. That's our acronym, if you like. And that reaches out across the network, runs as a service, reaches out across the network using ping, nmap, SNMP, WMI, SSH, and all of those kind of protocols to query devices. Is it alive? Does it have an IP address? Does it have the WMI port open? Right, it's probably a Windows device. Do I have credentials to climb aboard? And so on. And what that allows us to do is very, very quickly build up a picture of the estate. And as you can see here, a couple of the sort of unique selling points here are if we have big co branch and big co HQ. So as your customers are either geographically diverse or based upon network topology, they're not necessarily connected together, we start to build, and it won't be the last time I say this, that single pane of glass view of a customer's perhaps disparate estate. And so, as you can see here, we would deploy one or many pads. And as Ian discussed, we actually store our data inside AWS, and we're a platform that was built for and in the cloud. So we're not an on-premise system that we moved up to the cloud, and I think that's an important differentiator. Okay. So that's the sort of architecture that allows us to reach out across the network. So I mentioned lots of protocols there, and really what this is a set of probes. It's like our man in the environment who's running those queries out across the network. And what we're really interested in, and as much as we will find everything that's got an IP address, what we're really interested in initially is workstations and servers. Now that's whether they're physical or virtual machines. We will climb aboard where we can if we have the credentials and the network capability, and we'll do a full hardware and software inventory. And that, of course, allows us to start to understand everything that's out there. Now, if it's a virtual machine, we notice that based upon our queries, and we'll, if you like, check a box and say that's virtual, and I'll come back to that a bit later. But here you can see some sort of high-level dashboarding that will tell us things like computers by BIOS age, one of those statistics that's come in and out of fashion depending on what vulnerabilities about at the time. But it's useful to know, to identify machine age, perhaps. Servers by operating system type, and you can see here that we can start to twist and turn that detailed information as we wish. Now, I talked about augmenting data. One of the great things we also do is if a customer has the ability to subdivide their network by their network topology, so they know which IP ranges belong to which building or which floor of a building, which some of our customers do, which is fabulous. It allows us to automatically draw a map, or say, what about floor 4 of building 6 in, Canada Square or something like that. And I'll come back to that later. It's not just about building a pretty picture, but it does mean we can build pretty pictures. So I'm going to dive in from a dashboard to some actual data, because I just want you to understand the sort of foundational elements of the data we collect. And I'm going to pick on one I know, so I'm no surprises here. And cancel that, sorry. And I'm going to pick on this, and as you can see, this view is a data grid, and what this really is it's like a live report on our database. So it allows you to query the database as you wish, and if you're trained by us, you can configure this. You can move columns about, you can add and remove columns, and you can make it your own, add your own personalizations. In addition, of course, you could export that data. So if you said all Windows machines export, you can go and do things in a spreadsheet for you. Okay, but let me show you the data that we collect. So typically, and this isn't every data point, we collect hundreds. But computer information, owner, I'll come back to that. But description, Will's machine, his name, operating system version, system UUID, form factor, DNS full name, IP address, and as I said, we could then augment that with a location. And as much as I'd love to be, I'm not actually in Charleston, but this is my demo system. BIOS version, BIOS release date we talked about. And if we can plug into Active Directory, we can even get that information from Active Directory. Which OU does this belong to? Which again allows you to subdivide your reports and make sense of your customer data. Show me my machines by logical unit, effectively. Whether it's a server or not, whether how much RAM, CPU speed, processor count, total core count. Now, not so important for something like a workstation or a laptop, but definitely important in the server world when you start talking about licensing and software. But you can understand that there's a huge array of that low-level data. Again, asset tag, serial number allows us to reach out to the manufacturer to carry that warranty information. And as you can see across the top here, it's, monitors. What monitors were plugged in when I did my audit? What disks? What logical disks? Memory modules? Computer processors? But really, what we're sort of super excited about at this stage is perhaps discovered software. So we call this signatures, and we're going to look at all of the software on my machine. And I picked these out because this is everything from, let's say, Windows Internet Explorer. or even things that don't necessarily have something in add remove programs, so the bio API framework. And it's important to note here that we get this low level information with this, the right down to the point version. So if we know there's a vulnerability or something in a particular version, really powerful information for the IT service management team. And the technicians. But actually, when we start to look at software management or someone a bit higher up, you don't necessarily want to know this information. You want to know, how many versions of Internet Explorer have I got? How many installations of 9, 10, 11 have I got? So that's where we augment again, and this is a powerful service we have. So this is our global recognition service, which takes that information and applies software product version information. And when we can, we don't support every piece of software in the entire world. It'd be crazy to suggest we do. But what we do is we allow our customers to say, hey, I found a piece of software that you don't recognize, please normalize it. Or you're never going to recognize that. It's something we use to build submarines or something. We're gonna name it ourselves, thanks very much. So customers have full ability to augment that database. Now, where we augment it, we do our best to add value. If there's an RRP, if there's information about end of life, and it depends. We obviously, the Microsofts and the Adobes of this world, we enrich a great deal, and some of the freeware stuff we enrich much less, but we very much use our customers to drive that information. So anyway, and I don't want to sort of bore you or get caught up in that low level information too much, but I want you to know it's there, so that as we talk about the sort of high level ideas, you've got an understanding of that foundational elements behind the scenes. So of course, if I take this low level information and I say, okay, regardless of machines, what software have I got? I can do that same thing. So I can look at it from a holistic level, and I don't need to look at it from that low level information. I can do exactly as I suggested before. How many versions of Chrome have I got? And Firefox and Safari, SQL Server, Skype. I can look at the top 20 workstation products, so no surprises here. Office Professional Plus, Visio, Project. It is my demo system after all. Okay. Server software. So what software have I got installed on my server? Not sure I'm happy with Firefox being on my servers. There's something I can drill into and look at those servers and understand. So already those use cases are starting to present themselves. So that's all very well. So we have these probes that reach out and collect information, and the way we're architected is exactly that our pad has probes, and we add to those probes iteration after iteration, release after release, and we start with hardware and software. We also have a probe that does hypervisors. So right at the beginning I talked about whether something was virtual or not as I inventoried it. What about what hypervisor it belongs to? So if we're allowed to, or able, or provided with the credentials to reach into a customer's hypervisors, whether they be ESX, Hyper-V, Red Hat Enterprise Virtualization, we can start to do things like host to guest mapping. So inside Asset Vision, even in a disparate estate that's got a mix of technologies, we can look in one place, and again, with a pretty map, if I know where they are, what are those host to guest mappings? What virtualization technologies have I got in play? And so on and so forth. So really starting to build that picture up probe by probe, technology by technology. There are tens of these probes, and I'm not going to go into all of them. I'm just going to call out a couple more before I switch over to our lovely 5 favorite data points. The reason I'm mentioning it is it describes our agility, that as we find a technology that perhaps a prospect requires or that is new in the industry, we can build upon the network capability that we have to start to either increase our WMI query or our SSH queries or whatever to develop more and more information collection. The last big one that's worth mentioning here is SQL Server, and this is always valid, whether it be an on-premise or moving to the cloud or whatever you're doing. Understanding a SQL estate is key, and whenever I've sat with customers, I always enjoy watching their faces change color as they do a SQL discovery. And that discovery starts with, is it installed? And those of you on the call probably already know, I don't actually care if SQL's installed. What I care about is whether it's got running instances. So we see, is it installed? Are there running instances? But we also gather, what edition is it? So we know that we care about that an awful lot. So if it's Express, don't care. Standard, don't care so much. Enterprise, care an awful lot. Yeah, so we can start to build up a picture of the trouble in our estate. And we've talked about and we've witnessed the expansion of SQL ghost towns as people clone virtual machines that have enterprise SQL on, and suddenly you're in a lot of trouble. If we're allowed to query using another probe, we can actually gather low-level information about whether that SQL server is being used. So we actually use trace, I'm sure you've heard of it, to gather things like reads, writes, and row count, so how that database is being used. And that will tell us if there are idle databases out there, databases that are not being used. And of course, layering that on top of our detailed hardware and software inventory, we can start to understand, well, this enterprise edition is installed on this piece of tin that's got this many CPUs, and I understand. Okay, so it's building up a picture. Now, it doesn't stop there. Like I said, we've got tens of these, and I'm going to call out two more very quickly because they're incredibly important for what we're talking about today. So we said to, again, our developers, well, this is all very good. This is all on-premise. This is very nice. We've got physical and virtual. What about what's in the cloud? And so we developed a set of probes which reach out to the APIs of the cloud providers. So today it's AWS, Azure, and GCP. So customers can put in their own credentials, their own account information, and it reaches out through the API just like they were logged into their AWS console, perhaps, and it pulls down the information about their, in this case, EC2 instances. And you can see, you should recognize this kind of stuff. So instances by type, whether it be M4 large or M1 small, by zone, EU West, EU East, those kind of things, reservations by end date. And we can go into detail of the instances, the sizing, what devices they've got, the tags that are applied to those, and all of that. So suddenly, that single pane of glass I was talking about earlier is no longer just that on-premise. It's on-premise and in the cloud. Oh, multi-cloud too. So we can start to understand that. Now, if someone's just starting their move to the cloud, this is likely to be empty. But as we move to the cloud and we take a server off out of the on-premise estate and move it to the cloud, we want to see that happen. So we would have a scheduled probe which would go and collect that information, and we could see that transition happen before our very eyes. Now, this is another important feature. So as we talk about, so that's all very well. So I can see my servers in my estate, and I can see what I've got in AWS, and I can understand how I'm paying for it based upon product. But what about if I'm going to move a server that sat there and perhaps it's a massive heaving thing, but it's been idle for years, and I don't know that. I'm just thinking I need 24 CPUs and a billion gigabytes of RAM and all the rest of it. So we developed another set of probes, and this, and I'm going to show you some data here. And what this probe does is, again, agentlessly reach out to the devices and ask them performance information. So what's your CPU doing now? What's your memory? Network send, network received, those kind of things. Disk I/O. Okay, so we can actually query devices remotely again, and this is important because it's speed to value, right? So we can go to our customers and we can understand what's in their estate and how it's being utilized very, very quickly. Now, we wouldn't switch this on for 1,000 servers, and check every 5 minutes, but we can certainly configure that such that it works for us. How many days data should we collect? How often should we collect it? And it allows you to see this kind of information that you see on this screen, and this is real data from our lab. Now, we could quite simply do a performance graph, and here's one I generated earlier. So, this machine was obviously switched off during a period of time, and we can see the sort of peak usage and so on. And so that could build up that information. But also what we can do is generate averages, and using some sort of simple red, orange, green indicators here, we can look at this machine, typically maxing out at about 50% CPU over a period of time. I mean, that's a fairly high average, but I've worked with customers that say if our machines use on average less than 80% CPU, it's the wrong size, buy a smaller one. Yeah, so we can work that out. And then as we start to venture into our cloud migration world, we can start to try to generate that information automatically. So when we collect the information from AWS, Azure, and Google Cloud, we also get a list of the products and what they look like. So that would allow me to say, right, this machine, what does it look like? If I were to match it just on inventory, yeah, like for like, what would it look like and how much would it cost me a month? But based upon perhaps 20 days of performance data, what's its real size? It's like actually a much smaller device and a much lower cost. Okay, so those are the kind of data we collect, and that's the kind of value that we add for that cloud migration. But really and truly, you know, an awful lot of migration products, you would use this as a guide, but there are specialists that have to drive these tools. But what's really important is we're identifying the shape of a moving estate, because some of it's going to be on-premise, some of it's in the cloud, some of it's physically installed, some of it's a web application. And I'll come to that next. So hopefully, quite a long introduction to the agentless technology, but hopefully you can see the expanding capability of that and what it means and how quickly you can get to value from there. So let me cross across the border, if you like, and what happens if I install an agent on the device? So an agent allows me to generate those 5 favorite data points. And another quick picture to talk about that. So the agent's depicted by the red blob this time. And this sits, I've got one on my machine. So every time I move my mouse and I interact with an application, there's a little timer running. And it collects that information all day long, and then it sends it back up via the internet, whether I'm out, you know, like I am now working from home, whether I'm in the corporate office or on a customer site. It's collecting that information all the time. I think that's really important to note. Passes it back up via the internet, back up to AWS on a daily basis. Now that information is typically hundreds of K, 1 to 200K a day, which is, you know, multiplied by 100,000, quite a lot, but actually individually it's less than the BBC homepage. So what does that mean? So again, hopefully the last low-level data screen I'll show you, but I think it's really important to do so. And this allows me to see, as my network catches up, there we go. This allows me to see those 5 favorite data points. And you can see here, luckily it's all me, I do have it filtered. So what are they? Who's using what from where for how long and how intensely? So Will is using Google Chrome from his laptop for about 2 minutes and about 33 keystrokes. Really important to note, unique selling points for us here. This, we don't have to tell it what to look for. We don't have to configure it for Google Chrome. It will catch anything that is a windowed executable in the foreground of a user's desktop. So it works in user space. So as I interact with an application, exactly like I'm doing now, it's going to say Will's using Google Chrome. I move my mouse, I click, I interact, I use the keyboard. And it collects that information. If I stop and pause to talk to you guys, what happens is, in a moment or two, that stopwatch will stop. So this is not open and closed data. Yeah. So there's 2. We don't have to tell it what to look for. It's not open and closed data. This is real interaction. Last but by no means least, if I scroll right to the right, you'll see that in fact it collects it at the executable level. So this could be Chrome, this could be Firefox, this could be Outlook. This could be my secret app I'm not supposed to use in the corporate environment .exe, my thumbnail app, yeah, my portable application. And we see these on a daily basis. What we then do is, of course, we'll climb up the processor tree. We'll work out what product it belongs to and what software signature, if you remember my first display, and therefore what software product it belongs to. So it's important to note those key things. Now, why keystrokes? Keystrokes give us this idea of being able to say, well, in this case, Adobe Reader. I used it for about a minute. 0 keystrokes. I didn't even do Control P. Yeah, I read a PDF, not a very long PDF, and and it was useful actually. December 28th, it could well have been my Christmas payslip. But so the idea being here is I can identify correct usage. If that was Acrobat Professional and that was all I did, then potentially that's incorrect usage, and I could perhaps be swapping that out for a read-only type application. And of course, when we start looking against things like Visio, Project, and high-priced, high-value software, even when people are license camping because they're jumping in it first thing in the morning so they make sure they've got a concurrent connection, and closing it last thing at night, we're going to see zero usage. So really important. But you said, Will was using Google Chrome. So that's no good to me because we don't know what Will was using inside Google Chrome. And I think it's important to note that we've had this technology since before I started, so many, many years. We have plugins for Internet Explorer, Firefox, Safari, and one more that escapes me every time. And what that allows us to do is configure web applications. So based upon a URL pattern or string or anything that we can identify by a regular expression or pattern, we can say this isn't just Google Chrome, this is a web application. So is it Office 365 Word? Is it Google Slides? Yeah. Is it one of the G Suite? Is it one of Office 365? And then suddenly, instead of saying Will's using Google Chrome, we can say Will was using Salesforce, or Will wasn't using Salesforce, or Will was using Marketo. And it allows us not only to identify the true use of those potentially invisible applications from a sort of shadow IT perspective, but again allows us to understand the usage of applications, whether they be physically installed, web-based, bespoke, internal, external, paid for, free. Yeah, and so suddenly that allows us to do all manner of things that we were talking about before, right sizing, looking at the right number of licenses for a particular application, but it also allows us to manage transition. And so an example might be, and Raj mentioned it right at the beginning, here's a dashboard that queries that data in a slightly different way. I do apologise for the delay. There we go. So talking about Office 365. So we can interrogate your Office 365 account, but we can then apply that to that usage information. Office on-prem days used, Office 365 web days used. Yeah. So as you pull out those use cases, we can start to build dashboards to identify usage, and whether we broke that down to see who's using the things that require us to buy an E5 or an E3, and whether we want to work that out. Another example might be a web migration project, and this again is a dashboard that we generated to talk about moving physical machines to Chromebooks. So you can see a set of machines that are using things like Visio that don't have a web-based equivalent, machines that have no usage on except for things that we've deemed or that your customers have deemed okay to be running on a Chromebook. So, you know, all web-based applications. And so we can use all of that information I've showed you today, but just for another use case. And of course, there's all manner of configuration we can do here. And again, worth noting that if your customers want to augment asset vision data with their own data, whether or they want to add another column to the database, is completely extensible, so we can always augment the customer's information. And in fact, typically we'll do that automatically as part of an engagement. So whether people say plug it into Active Directory, or I've got a database, or what about John's spreadsheet? Yeah, anything, all of the above. And I've got a little thing down here to remind me to talk about integrations. We have the ability to pull data from, you know, SQL, Oracle, flat file, and we also present an API, whether it be HTTPS based, bespoke API, or more recently we've incorporated OData, which would allow you to use your own systems to interrogate asset vision once it's done the collection, or in fact plug something like Power BI in and collect that information. So I've pretty much told the story, I think, from, you know, how we collect that information, how we've developed our probes to, you know, to address a sort of moving target of an estate that's becoming very much hybrid and multi-cloud, how we can use that usage data, and some example use cases. Now one I haven't mentioned here is perhaps one that was a bit of a curveball that was sent to me a little while back. Was, well, you know where my machines are. I've told you what the IP addresses are, and you know which machines aren't being used. Can you tell me how my offices are being used, my commercial real estate? And that was an eye-opener for me, because absolutely, of course I can. So we can apply all of that information and say, well, we know who's using what from where for how long, so therefore we know, if we know where they are, we also know what parts of the building are being used potentially. And so you can see that those use cases, and I think Ian alluded to it earlier, hopefully the lights are coming on in your minds about how this might be used. And I'm glad to hear a use case I've never heard before. Now, I could talk about this middle tier here, but I think I've talked enough for today. But really, we can identify, I said right at the beginning, what about if, Firefox version 1234 is at risk, there's a problem, there's a vulnerability? Well, of course we can report on that. Can I identify products as unwanted, blacklist? Yes, of course you can. It's just a flag, and then we'd have a dashboard. Vulnerable machines. We collect patch information when we interrogate those machines as part of the inventory. So we can identify things that aren't up to patch standards. Expiring agreements. If customers add, augment with their entitlement information and their agreements, we can of course report on that and the associated exposure based upon usage should we want to. Okay, so as you can see, a huge broad range of data we collect, single pane of glass view, multi-geography, multi-network, multi-technology.